Hey, how's it going? My name is Ois. I welcome you to my Groovy course. It's been almost 5 months I have had a haircut because I've been living in lockdown. Anyways, that's not stopping me uploading the videos on YouTube. So this video is going to be a crash course for Groovy. Let's get started. Groovy is a powerful dynamic language with a static typing and static compilation. Also, it is based on Java platform. So if you're a Java developer, it's going to be pretty easy for you to pick this up. There are a few reasons that I would like to tell you that why would you want to learn Groovy. A few reasons why would you want to go with Groovy and use Groovy instead of Java. Groovy is designed to be less verbose than Java. The syntax is less complicated and follows a simple structure without unnecessary semicolons. So it has an integration with Java. Java and Groovy work very well together. You can easily make back and forth Java class calls and it will work fine. There's no need for a special language constructor or third-party library. You can use frameworks like JUnit as well. Well, it's easy to learn if you're a Java developer. So Groovy programming language is much easier to learn, and much of the code that you will write, it will compile and work as expected. The learning curve for Groovy is small. It is not difficult for someone who is proficient in Java to get started with Groovy. Also, I want to mention Gradle. Gradle is a rapidly growing popularity build tool. Google has been using it for their Android development, so you don't need an in-depth knowledge of Groovy to use Gradle at the basic level, but knowing how Gradle works can get you to a pro level. So Groovy is pretty cool. You can do a lot of cool things with it. Groovy also used in Grail's web framework. So you can see using Groovy, you can build web application as well. So it's pretty cool. Now I'm going to go and set up my system for Groovy and let's get started with Groovy. Get the Groovy installed on a Mac. So I'm going to click on download. And then here in downloads, we're going to go install Groovy 3.0. 4.0 is a bleeding edge version, which is in alpha state, so we're not going to be using it in this tutorial series. If you're on Windows, it's very simple. Just download this Windows installer and install through that. I'm going to go and use Brew to install Groovy. So if I open up a terminal, let me just go in terminal. Alright, so on terminal, I can see I have already installed a package manager called Brew, Homebrew actually. So the command is fairly simple. It's just brew install Groovy. So let's copy that and paste it here, press return, and that's about it. And it's going to go and install Groovy. Groovy is based on JVM platform, so it requires Java to be installed on your computer. As you can see here, it's downloading OpenJDK 14.0.1 as well, because without Java, Groovy won't work. Okay, so Java has been installed, and also we have Groovy installed on Mac. So I can see Groovy version 3.0.5 and JVM is 14.0.1. I'm going to be using IntelliJ throughout this course. So I'm going to go to Toolbars. This is an application from JetBrains. I'm going to click on install and it's going to install the latest version of IntelliJ. But you can also use VS Code, which is a free text editor that you can use to pretty much write any kind of code. So we're going to start by creating one file in VS Code and we will create our first most famous Hello World program in Groovy. So I'm just going to create a folder here and I'm going to name this folder Groovy, and then let's open that folder in our VS Code. So let's go to desktop, Groovy, and let's just open that up. Alright, so now in this folder I'm going to first of all create a file. So I'll just say hello.groovy. Okay, now here I'm just gonna zoom in a bit. So we're gonna be creating one class, so we just start by a keyword class and I'm gonna just say main and then have a square brackets. Then we're gonna create a static method. Return type is void and I'm just gonna name it main. Within our main method, I'm going to give an argument, which would be args, and I'm going to define its type as string of array. Within our main method, I'm going to use a keyword println, parentheses, single quotes, and just type the message that you want to print on the terminal. In this case, we're going to try printing hello world. Let's save the file, and I'm going to go to terminal, and the way you execute this Groovy file on terminal by executing this Groovy and then space and the name of the file. Press return and you will see hello world printed on the console. As you can see, we actually ran our Groovy file, and congratulations, your Groovy file is running and your hello world is getting printed. Now, a couple of things I want to talk about terminal. So we used Groovy keyword, which starts the processor that executes Groovy script. Single line Groovy scripts can be specified as a command line argument as well. Also have a Groovy shell. I'm going to take you to terminal and I'm going to type Groovy sh, which is going to start the Groovy shell, and we can execute Groovy code interactively by entering statements or whole script line by line to line into shell. So code is executed on the fly. Let's press enter and let's wait for shell to come up, and then I'm going to try running that print line keyword. So I'll type print ln hello world, enter, and you got this hello world. So if I do 3 plus 3, it's going to be 6. I can do 2 plus 2. It's like executing the numeric where we have addition. We can do 7 minus 2, which is like a subtract. And you can see in shell what code is getting executed on the fly. I'm going to press Ctrl C on terminal to get out from this Groovy shell. And also we have a Groovy console, which starts a graphical interface that's used to execute Groovy code interactively. Execute Groovy console, simply type Groovy console starting with capital C for console. I'm going to press return and it's going to bring up the console for me, and I can start writing some scripts there. So here I'm going to just use println, and I'm going to say hello world, and then I'm going to click on this button, which will execute this code, and I can see the result here. So I can have a multiple lines here. For example, I'll just say 5 plus 5, 9 minus 2, and then we can also have another print line saying, do you like Groovy? Alright, let me just execute this code. So here we got, do you like Groovy? And the result actually didn't came up on the console. The reason for that, it was executed, but we didn't print the result. So what I want to do is print ln, and I'm just going to print the result for these. Okay, now if I execute, you should see 10 and 7 on the console. So it's pretty nice. You can use Groovy console to interactively learn Groovy and try out some code. We're gonna try using Groovy console as much as we can, because it's much easier to learn the programming, and then we can see the execution of our code straight away, so we don't have to go and open new files. Let's learn some basic syntax of Groovy programming language in the next video. Okay, so welcome to the second video of Groovy tutorial series, in which we are going to talk about syntax in Groovy. So we're going to start by creating a new project, and we're going to take that project and then use that throughout the series. I'm going to be using IntelliJ as my IDE, and you're going to make sure Groovy installed at this stage. So the way you can check it, you go to terminal and type Groovy space -- version. You get to see the version of Groovy. I've already shown you in the last video how you can set up Mac and also the Windows. So basically, we're going to go open IntelliJ. I'm using IntelliJ Ultimate version. You can follow along with me using any text editor, VS Code, or even IntelliJ Community version, which is completely free. So I'm going to click on a new project, and I would like to create a Groovy project. So here's from the list, I can select Groovy, and then I can specify the Groovy library, which already selected for me. Then I'm going to click on next, And on desktop, I would like to create just a Groovy project. Let's click on finish, and we will have a Groovy project created in IntelliJ. So here's a source folder. And now within the source folder, I would like to go and create a new Groovy class. Now Groovy and Java, work very well together. So this is why basically IntelliJ is giving me a suggestion. Maybe I want to create a Java class, but I don't. So I want to create a Groovy class, and here I can select the class here, specify the name. First of all, I'll just say example. Let's create a class. I'm going to go and create a function, which is going to be static function. Don't worry, we will take a look at what are the functions in Groovy. Now in IntelliJ, I can open a built-in terminal, which is here. I'm going to zoom in as well. So here, I'll have to go to source. So I'll do Groovy space source/example.groovy file. I'm going to press return, and you will see hello world printed. Now we executed this class file. I'm going to move my terminal to the top right, and here I'm going to write Groovy code, and then here we'll execute that. So yeah, that's our setup for this tutorial series. Now we talk about syntax. Okay, so what is syntax? Well, syntax is a term in programming language. Syntax is something that some of the rules that you have to follow so that the programming language compiler can understand what you are talking about. For example, here I created a class and I named it example. And then we have this function. I understand you're not aware of what is this, but this is a function. So how do we know this is a function? Well, we wrote it, we know this is a function, but how does the compiler understand that this is a function? Compiler understand because we followed certain rules. So we started with the keyword static, a keyword void, and then the name, and then this parentheses, and then we added this code block here, and then here we give 4 spaces and 4 spaces here. It's like a human language. So if I'm talking in English, you must be able to understand English to follow along this tutorial. If you don't understand English, you can't follow, right? Similarly, compiler looks for certain rules to be followed. If we didn't follow these rules, compiler will not be able to execute our code and will throw an error. So syntax is something that we need to follow to be able to write the code which will do exactly what we are intended to do. If we don't follow the proper syntax, our program will break and won't be able to compile. We have tokens in Groovy. A token is either a keyword, identifier, a constant, a string literal, or a symbol. We have this line, println hello world. So there are 2 tokens here. The first is a keyword, println, and the next is string literal in parentheses. A string literal is simply a string, a paragraph, or some text wrapped in single quotes or in double quotes. A keyword is a special word in programming language. It's not just in Groovy, but any programming language there are keywords, which means that the keyword have some special meanings and they perform some actions. We'll talk about keywords just in a minute, but now take a look at this is a keyword and this is a string literal. We'll get to identifier and constant as well, but for now, just say these things can be a token in Groovy. Now sometimes we want to write some message for ourselves. I would like to say that this line will print hello world to the console. Now if I give a space here, I'll say this line will print hello world to the console. Okay, now what if I want to run this code? So let's go to the terminal and I'm going to say Groovy src and then example. I'm going to press return and it will throw a whole bunch of errors. So there are 4 errors. Comments are a common concept in pretty much all the programming language. Comments allow you to write some text a message, a paragraph, or some explanation about the code. The way you define comments, first let me mention there are single line comments and there are multi-line comments. So here we have a single line, so I can define a single line comment. So the way you define that is by prefixing your line with double forward slash this way. Okay, so now as you can see, we got this line, and this is not read by compiler anymore. So what I mean by not read by compiler is when I run this code, and compiler is going to go and look for this function to execute, and then it's going to find, oh, there's a line here which says this line will print hello world to the console. Well, it finds that there's two forward slashes before this line. So what it means to compiler is that please ignore this line, do not do anything. So comments don't run in the code on the runtime, or they don't get compiled. So they are just purely for us to come back to the code and understand what we were doing with this code. So if I run now, I should be able to see hello world right here. There you go. So we understand the single line comments now. I'm going to show you how you define multi-line comments. So the way you define multi-line comments in Groovy is by / static, and then you press enter, and IntelliJ is smart enough to finish that for me automatically. So I'm going to say this is the multi-line comment. Now, if you talk about how important the comments are, well, they are really, really important because, any developer write code today will not understand the code that he himself wrote today. He won't understand tomorrow because there's too many code to understand. So the only way to give you an idea why you did that particular logic or why you wrote that code is by defining a proper comments. And no code is good enough without comments because nobody can understand, in the future. So make sure when you're writing code, you write proper comments, which will be helpful for you in the future. Next thing I would like to mention or talk about is semicolons. If you are coming from a Java background, you understand if you don't type a semicolon here when you're doing println, or in Java is system out dot println, and if I do hello world second, or maybe we can say logged by Java. Okay, so this is a Java thing. Now if I run this bit, you should be able to see hello world logged by Java. So now if we were writing Java, if you have missed this semicolon here, so this is the one I'm talking about, semicolon. So if you would have missed the semicolon, then Java won't run, because in Java you need to be very careful defining your semicolons. But in Groovy, it's optional. So if you define semicolon or not, it's up to you. Well, I would prefer that having a proper structure. So if you're not using semicolons, don't use throughout the code. If you're using semicolons, use throughout the code. So, keep the consistency in your code. Now, next topic we are going to talk about is very important. If you're coming from a Java background or any programming language, you have to have that. It's called identifiers. So mostly languages usually use the term called variables. It's basically defining a memory location and storing some value into the memory. Well, we can store numbers, strings, booleans. When we get to the data types, we'll talk about that. But for now, just have a look how we define variable or identifier in Groovy. It's very simple. All you got to do is just use the keyword def and then space and then the name of the variable that you're trying to define. So I'm going to say ABC equal to, let's just say 1000. Doesn't really matter. Now if I do a println and I use ABC, save, and let me just comment these lines out. So in IntelliJ, if you press command / it will automatically comment that bit out for you. Now I'm going to run the code. and we should be able to see 1000. Now we are actually not printing on the line this 1000, we're just printing ABC. So what happens here is when the compiler goes and read this line, it looks for def keyword and it says, oh, we're trying to define an identifier, or we can say variable, which is basically a memory location in your RAM. And it says, okay, I'm going to store 1000 into this location. Next line, when it gets to here, it says, I would like to print out ABC. But ABC is like a memory location, which we already defined up here. So if it doesn't find ABC here, it will throw an error. If it finds it, it will print the value which was stored in this memory location. I kept saying memory location. A memory location is just a variable. A variable itself is a memory location. So I'm gonna clear the terminal and I'm going to run the Groovy file again, but this time I'm going to just define this variable down, save, and then run the code. And now it says there's one error, and the error should specify, it says a parent variable ABC was not found in a static. So basically what happening is when the compiler comes here, it says I'm going to print online this ABC, and it looks up the memory. It doesn't find that ABC into the memory, and that's when it throws an error. The reason for that, because we haven't defined ABC, so this is going to throw an error. So you have to define the variable first if you want to perform any operation on that. Next concept we talk about is white spaces. White space is a term used in programming language such as Java and Groovy to describe blank tabs, new lines, characters, and comments. White space separates one part of the statement from another and enables the compiler to identify where one element in the statement ends and starts. So, for example, we define a variable here. Let's just say we define a variable x equal to 5. Now, in the following code, there is a white space between the def and the variable x. So this is because compiler needs to know that def is a keyword which needs to be used, that x should be a variable name, and that needs to be defined. So here we can see we have to have a white space which tells the compiler that, hey, this is a keyword and that's the name of the variable that we're trying to define. So white spaces are very important, but if I give a white space like that, it doesn't really matter because compiler will just ignore these white spaces. There's another concept that we can talk about right in this video called literals. Well, it's very simple. We've been using fixed values in Groovy. So this is a fixed value, and we had this string which was like a fixed value. I'm going to get rid of this print and get rid of this as well, and let's just zoom out a bit. Okay, that's better. Now, a fixed value is something that you define. For example, I'll just say 5, or I'll just say 7, or I'll just use double quotes and say hello world. Okay, I can use that single quotes as well. So Groovy language has notions for integers, floating point numbers, characters, and strings. Here's an example of integer. We can do .5, that becomes float, and we have this string literal, and then we can also have a character like single quote C character. So you can define these literals. In the next video, let's talk about data types. In this video, we're going to talk about data types. Data types are a pretty common concept in pretty much all the programming languages. I would say without data types, there is no programming language whatsoever. Data is something that we work with in programming languages, so there has to be some data types, right? So as I said, in programming language, you need to use various variables to store various types of information. Variables are nothing but reserved memory location to store values. Look at an article which explains data types, programming language called Groovy, and in any programming language, you need to use various data types to store various types of information. Variables are nothing but a reserved memory location. So you gotta remember this bit, okay? This means that when you create a variable, which we created in the last video, you reserve some space in the memory to store the value associated with the variable. We already talked about it. So you may like to store information of various data types like strings or character or wide character. We got integer, floating point, boolean, and so on. So all of these information can be stored in a variable. And there are different types of data available in Groovy. So we got different types of data here. We have byte, we got short, we got integer, we got long, float, double, character, boolean, and then string. I'm going to read these one by one. A byte is used to represent a byte value. An example is just 2. We got short, which is just used to, represent a short number like 10. Also, we got integer, and this is used to represent whole numbers as 1, 2, 3, 4. We got long, which is used to represent a long number. An example is like 10000090. We got float. Float is another number which is used to represent 32-bit floating numbers. An example is 12.34. Okay. We got double, character, boolean, which is just true or false. We got string. A string is something we're going to be using a lot. Like we've already created a program which print out hello world, which is a string. Now let's go and type some data types in the text editor that we have. So for example, I'm going to start by creating a function. I'm going to name it a main, and that would be a type string, array, name it args, and then I'm going to define some data types. So the first one we have is byte. So example, simply you go type byte, and then define a memory location, which is a variable. And for the name, we can just choose x is equal to, and I'm going to just specify 2. Adding semicolon or not adding is optional in Groovy. Next, we have short, int, and long. Let's try those. So short is something that we can define. So we'll just do y equal to 23. And then I'm going to use long. I'll just choose s equal to some long value. And then we got double equal to, let's just say d equal to 12.50. Okay. Next data type we have is string. Start from capital letter. Let's go back and test it. So we got float, double. Now there's a difference between float and double here. So on the float, it says this is used to represent 32-bit floating number. Okay, and the double is used to represent 64-bit floating numbers. Now these are like mathematical terms. If you know basic math, you should be able to understand what this means by float and double. We got character, boolean, and string. So let's type those. For the character, char, and I'll just do c, and then for example, a character can be, let's say, character defines a single character like this, A, B, C, D, whatever it is. So I'm just going to use the same one. We'll just do single quotes A. Next we have string. I'm going to use str for a variable name equal to, we use single quote, and I will define hello world. Strings or series of characters. So we have a series of characters like HELLO space WORLD. Now we've already seen byte, integer, long, double, character, and string. Let's try printing them out into the console. So I'm gonna type a function name, which is a print. We use println. It's like a function in Groovy. So all of these, this is the main, that is a function. We haven't talked about functions. Functions are a really important topic in Groovy, but we'll get there. For now, just use if you type println and define a value inside this parenthesis, it will print that into the console. So here I will type X. I'm going to make a copy of this and I'm going to use Y here. And then we got S. Then we have D. Then we got C. All right, and then I'm going to make another copy and we got str. Okay, I'm going to open up a terminal and here I'm going to type groovy space source data types.groovy and press enter, and you will see printing 2, 23, 23, something like that. So I'm going to just mark that so we know what we're talking about. So here we got 23, 23, 42, 12.5, a hello world, and we got all the data printed in the console. Let's go to article and let's start by looking at what is a bond of values. I'm going to read this line here. So it says the following table shows the maximum allowed values for the numerical and decimal literals. So here we got some sort of information which says byte can only have 128 to 127. Short can have 32,768 to 32,768. So what does that mean? Well, let's go to our code editor and let's find out. So I'm going to just hide the terminal. Here we got short, so I'm going to just remove that. Now we're going to start by defining short, and I'll just say sh equal to, and as it says a bond value. So the bond value means that this can only have 32,768 to 32,767. So what if I type 43 and then some number here? Now IntelliJ is smart enough. It's telling us that we are basically trying to add or assign bigger value than it can have. So let me just hover over, and it says assignment is not used, possible loss of precision from integer to short. So if I change this to long, the error will go away because long can have this much data, but short cannot have that much data. So before you specify a type of your variable, you're gonna have to make sure that for numericals, you have to have some certain limit. So here we got long, which is pretty long. It can have lots of data here, and we got float, which is like quite long, and double. You know, there's a lot of data that you can store in double. All right, so next up, we talked about some of the numeric classes. I'm going to read this line. So it says types in addition to primitive data types like byte, short, integer, long, float, double, the following object types. Here we have some classes. I know we haven't talked about classes in Groovy, but if you have some previous knowledge about the programming language, you should be familiar with these term class. In Groovy, we can import Java classes. We haven't talked about that. We will when we get to that section of the course. But we got java.lang.byte, .short, .integer, and we can import these classes to create this data type. And Groovy can talk to Java. So yeah, these are some examples that we've already seen, and we printed out these values as well. Welcome back. In this video, I'm going to talk about variables. Well, we've already been defining variables throughout the series, but let's talk a little bit about the keyword def and also defining the explicit type for a variable. So variables in Groovy can be defined in two ways, as we've seen already, using the native syntax for the data type or by using a def keyword. Now, to define a variable, it is mandatory to either provide a type name explicitly or use a def in replacement. We have seen the basic data types, and we created some variables using explicit data type in the previous video. Groovy also allows for additional types of variables such as arrays and structures and classes, which we'll see in subsequent videos. Variable declaration tells the compiler that please go ahead and then create a variable to this particular memory location. For example, if I use a static void main, and I'm just gonna do a strings args, and that would be a type of array, and we do a code block. Now within a code block, I will just define an integer x equal to 5, and then int y equal to 5 as well. Okay, given the code here, we have two variables. We got x and we got y, and x has a value of 5 and y has a value of 5 as well. Now this one is defined by using keyword def, and then second one is defined by using keyword int. Both are defining a value 5 for their placeholder, or we can say a variable. What is the difference between it? So if I just go, first of all, let's just try println, and I'm going to say value of x, and I'm going to show you the concatenate operator here, how to concatenate. So plus minus is just a simple addition and subtraction operator in mathematics. You can use them here as well. So we go plus, and I'm going to define a value of 5. Okay, now instead of value 5, I can just pass in the variable, and then I'm going to say plus again, and then I will just give a space here. It says value of y equal to, and give it a space as well, and then plus, and type y there. Okay, now if I run the code, I should be able to see value of x is 5 and value of y is 5 as well. Now given that, if I just go and change this to, for example, ABC, you will notice there is some sort of like a yellow line under y now. IntelliJ is smart enough, it says cannot assign string to an int. So before even we compile and run our code, we get to see an IntelliSense which telling us that, hey, you are actually trying to define an integer, but the value you're storing in y is a string, so you shouldn't do that. Now if I try to run this, let me just zoom out a bit. Yep, should be fine now. So now if I just print out this statement where I'm accessing this x, and here I'm accessing y. Okay, so let's just run this, and you'll see an error. It says cast object abc with the class java.lang.string to class int, and it throws an error. So if I go and change this to string, and now save the file and run this time shouldn't be a problem. It says value of x equal to 5 and value of y is equal to abc. So you can see the difference between, def and explicitly defining the type of data that you're trying to store in variable. So given that, you have a freedom to actually say, hey, I don't know what the data is going to be, so I'll just use def. Or if you know what the data is going to be, then you can explicitly define its type as well. Given the example, well, I want to give you an example. For example, you make an API call to, one of the server out there, and you don't know what it's going to return. So what do you do a type what do you do the type? So type should be, any data comes in, it just, you don't know. Now, when you know that in certain API calls, this is what you're going to get, this type of data you're going to get, then you can explicitly define its type as well, and it gives you better IntelliSense. Today we are going to talk about operators in Groovy in details. So here we got an article which tells us what are the operators available in Groovy. So here, first of all, let's read this bit. Okay, it says an operator is a symbol that tells the compiler to perform a specific mathematical or logical manipulation. We've already used a lot of operators since we started with this course. So here we have arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators. Let's take a look at arithmetic operators. Arithmetic operators are pretty common. Well, if you have passed your high school, you should know what is plus means, what is a minus, multiplication, subtraction, modulus, division, and then we got increment and decrement operators as well. So basically, it's pretty simple. Here are some examples. So if you type 1 plus 2, it will give you 3. If you type 2 minus 1, it will give you 1. You know, just a mathematical operation. There is not much to talk about. It's very, very simple. So in Groovy shell, if I go and type 1 plus 1, it'll give me 2. If I press 50 plus 40, should give me 90. And you can use 50 minus 40, that will give you 10. You can have 5 multiplied by 5, give you 25. You can divide 25, divide by 5, it'll give you 5. So all of the general math operators are available in Groovy, and this is like the basic thing in any programming language out there. Now we have this increment and decrement operators. Basically, they're like a short form IDE, and let's try to use them. So here I'm going to define def x equal to 5, and I will just say x plus plus, and then I will do print ln x. All right, now here the value of x is 5, right? But here we're defining x plus plus increment operator. Now when you do that, you will expect the value to be printed would be 6. So let's open up a terminal. I'm gonna run, oops, that was the video from the last, that was a file from the last one. So I'll do operator Groovy, and there you go, you get 6 there, right? So the value we're getting is 6, but we defined 5 here. So what's happening here? So let me go and type something different. So I'll do x equal to x plus 1. Okay, let's run the file again. We still get 6. So what is the difference? So basically, if you want to increment 1 to any integer, you can use this short form. Instead of defining like this, you can use increment operator, which is plus plus. Similarly, we can do with the decrement. So if I do minus minus, I'll just run the code again, and this time we should be getting 4. But you could write this in a way where you have this operator, and then we do x minus 1. That does the same thing, and you get 4. So basically, because these operations are very common when you're working with some sort of application, so that's why all the programming languages provide this increment and decrement short form. Let's go to the article and take a look at some relational operators. So relation operators allow comparison of an object. Well, we got some relational operators like double, equal to, negate, equal to, less than equal to, greater than, and greater than equal to. So if you take a look at this bit here, if we say true is equal to 2, we'll give you true. So in a simple form, relational operator will return true or false. Will basically give you true or false. If the condition that you are trying to achieve is valid, then it will return true, otherwise it will return false. So we have this first operator equal to, which tests the equality of two objects. It is mentioned here objects. We haven't talked about objects and what they are in Groovy. For now, just remember any primitive data type like strings, character, integer, boolean, all of them are objects in Groovy. We'll get to what is object, what does it mean in Groovy, but for now just remember that. Now, the first operator that is mentioned here will test the equality of two objects through IntelliJ, and let's try that out. So I'm going to first clear the terminal, and here let's get rid of this code. And now, first of all, I'm going to define a variable which will be integer variable, and I'll just say x equal to 2. And I'll do another integer variable, we name it y, and I define that 2. I'm going to use print ln function, and I'm going to use x equal to y. I'm going to save this file. Let's go to terminal and let's run this code. Let's press enter, and now this returns true. Well, why it is returning true here? Well, because 2 is equal to 2. So the equality check is happening on the values stored in these two variables. Let me just go and clear the terminal again. Now if I say y is 3 instead of 2, then we should expect false to be returned from this println function. So let's run the code again, and we are expecting false as a return value. As you can see, it is running false. Now, because 2 is not equal to 3, it is telling us that, hey, your equality check is not valid. That's why it's giving us false. Now, next operator is very similar to equality, but it basically inverts the operation. So it tests the difference between two objects. Now, if I change this equal to this negate, and now we'll run the code, then I will expect true to be returned, as you can see here, because x is not equal to y. And this is what it's saying here. Next operator that we have is greater than and less than. Very simple, we can check that. Let me go and change this to x greater than y. Well, the value is supposed to be greater than the value stored in y. So if I run the code, it will return false because 2 is not greater than 3. Now, if I change the value of x to 5 and save the file and run the code, I'm expecting true to be returned because this is true. 5 is greater than 3. Similarly, we can check with less than sign as well. So I'll just change this to less than, run the code, and I'm expecting false to be returned. The reason for that is because 5 is not less than 3. Okay, so we have these operators. Now let's just say you want to change this to, let's just say 5. I want to check whether x is equal to or greater than y. So what we can do here is we can add this equal to operator and then a greater than operator. Okay, I think it has to come like this. Okay, greater than equal to. I'm going to run the code, and that returns true because 5 is equal to 5. And if I change that to 6, and I will run it, and now I get to see this false. Okay. Now let's go back to the article, and here we've covered pretty much all of these. Okay. Now let's go to logical operator. So in logical operator, we have these three operators. So first one is and, second one is or, and third one is not. Here is an example. So it says true will give you true, true or true will give you true, negate false will give you true as well. Now these are very common in math. If you have passed your first standard or year 12, or even if you pass your fifth standard, you should be able to understand what does this mean, because in math logical operators are very common. Okay, but I'll still give you a quick idea what does that mean. Well, first of all, let's go and remove this code. Actually, let's not remove these variables. Now, what we need to do is we need to basically have true will give me true. So I can check for a couple of things here. I'll first do a println, and I'll say x greater than y and y less than x. So what's happening here? Well, this statement will return us true because x is greater than y. Is it? Well, it's not. So what we need to do is we need to do less than and then greater than here. So we can say x is less than y, which in this case is true because 5 is actually less than 6. So here we will become true. So this one become true. And then this one, y greater than x, will become true as well. So what we have here is true. And then for this one, we have true as well, which should return us true. Okay, so let's run the code and let's see if that's actually true. So I'm going to run this file and I'm expecting true to be returned. There we go. Now, if you pay attention here, we have a truth table. If you're in grade 5, you should be able to understand what is a truth table, and that will help you understand how to use this AND, or negate operators. We got a bitwise operator in Groovy as well. So we got this AND, OR, XOR, and negate operator. Let's go down and we got some assignment operator here. Well, assignment operators are pretty cool. We've been using it. There's nothing, rocket science about it. These are the assignment operators. So we got this plus equal to, minus equal to, multiply equal to, divide equal to, and modulus equal to. Okay, so it says this adds a right operand to the left operand and assigns the result to left. So basically, if I go back to the code, and now let me just do this, clear the terminal. I'm going to get rid of these two lines. And now let's say you want to add to x. So x currently have 5. Now what you need to do is we'll have to say x equal to x plus, let's just say 5. Okay, then I'll use println and print x in the console. Let's go to the console or terminal and press enter, run this file, and we get to see 10. Now in programming, this operation is pretty common. You will have to add certain numbers to specific values, and it's pretty common. That is why Groovy and many other programming languages provide these assignment operators, which makes it easier to add certain values to its current value. So if I want to add something like 5 to x, what I'll have to do is just do plus equal to, and then I'll add something like 5. It does the same thing. So I'll run the code and I get to see 10 again. Now I can add whatever the value that I want to add to it, and then it will add that. Okay. Otherwise, what you will have to do is you will have to do x plus that particular value. Okay, and it does the same thing. Similarly, you can use this assignment operator. Let me just go and use this with minus equal to 2. Okay, now we are expecting 3 to be returned. There you go. So we got 3 here, and it's basically the same thing. Okay, it's just a short form of defining. So you can do this with division, modulus, and multiplication as well. Now we have a range operator in Groovy. So Groovy supports concept of range and provide a notation of a range operator with the help of dot dot notation. Okay, so here I'm going to define def range equal to 0 dot dot 5. Now this just defines a simple range of integers stored into a local variable called range with the lower bound of 0 and upper bound of 5. Okay, so I'm going to go and then do that. So here we got integer 5. Instead of integer x is equal to 5, I'm going to change that to, for example, first of all, let's get rid of this. I'll just do def, and I'm going to do 0 dot dot 5. Okay, now first of all, let's try printing x, and let's see what we get. So I'm going to go and run this. Oops, not this one. I'm going to run this code, and I get to see 0 dot dot 5. Now, what if I want to get a particular value from 0 to 5? So I'll just do x get, and I'll just do index 2. Okay, and I will run the code, and there you go. I get 2 back. So if I say, let's say 6, and I run the code again, I will get an error. It says, well, this is not available in X. We have operator precedence that we need to talk about. So here we have some table which lists out the precedence of operators. So what this basically means is that if I go back to the code and I will create a variable, actually I'm going to not use this, but I'll use the Groovy shell. So let's type something 2 plus 2 multiply by 5 divide by 2. Okay, now what's going to be the result? Let's press enter, and result is 7. Okay, well, if you take a look at this one, let me just draw some diagrams. So let's just say 2 plus 2, 4. 4 multiplied by 5 becomes 20, and 20 divided by 2 becomes 10. But the answer is 7. Why is that? So let me just write that statement again. So I'll do this, and now it's 7 again. So what's basically happening here is that we have an operator precedence. So when this statement gets to the compiler sees, oh, I have addition, I've got multiplication, and I've got division. So what it does, it looks for operator precedence. So here we have a multiply, divide, and module. So multiply will be executed first, and then division, and then the modulus. And in terms of addition and subtraction, we will have addition happening first, and then subtraction. Okay, so let's go to our Groovy shell. So here, the reason why we got this answer is because the first time what happens is it actually ran this bit, 5 multiplied by 2 becomes 10, and then 10 divided by 2 becomes 5, and then 5 plus 2 becomes 7. So that's how we get 7. So have a look at this table here. That will tell you what is the operator precedence. Welcome back. In this video, we are going to talk about decision making in Groovy. Making is a very common concept in pretty much all the programming language. I've never heard of any programming language which does not have decision making functionality. And the basic building block of decision making is this if statement. This if statement will check the condition. So let me zoom in a bit. So here let's say we have a condition to check. We've already seen the logical operators. So let's say we have 2 equal to 2. That is a condition. If that becomes true, then it will go and it will continue the conditional code. Otherwise, it will just skip that conditional code and execute the next statement. Given that example here is that, so you start by defining if, and then you use parentheses, give your condition there, and then the code block start with the curly braces, and then you can specify statement 1, statement 2. You can specify any kind of statements there as well. So that's like a basic building block of decision making in any programming language. Now, given that in the code, we can do something like this. So I'm going to start by using this main method, and we just do a string. Then it's gonna take a name, which is args. So for example, here I would like to say if 2 equal to 2, then print ln, and I would just say on the console saying 2 is equal to 2. Okay. Otherwise, I want to do something else. I want to, check for this condition. And if the condition is not valid, then I want to run some other code, right? So what I will do there is I will use else keyword and then add a square brackets. Let me indent it properly. And then here I will just do a print ln and say 2 is not equal to 2. All right, so here we have a statement. So in this one, we will check for 2 equal to 2. And if that's not the case, then it will go and write down this 2 is not equal to 2 on the print line, on the command line. Okay, so let's try to executing this bit. So I'm going to use Groovy keyword, and that would go in the source, and we have a decision.groovy file. Press return, and you will see 2 is equal to 2 because this condition is true. So if I say 2 is equal to 3, and now I'm specifically making this condition false because we know that 2 is not equal to 3, and then once it's not true, it's going to return false, then it will not execute this line, but it will go to this one. Okay, so let's run the code again, and this time we say 2 is not equal to 2. So another thing that we can do here is something like this. All right, I'm going to create a variable. So I'll just do int x equal to 2, int y equal to 3. Okay, instead of using these integers here, I'm going to use the variable names x and y. And then here I will just say x is equal to y, and I will just say x is not equal to y. So now we don't have to change this bit, but we can change the values here. So let's go and run this code again, and it should say now x is not equal to y. Well, that's true because 2 is not equal to 3. Now another thing that I can do here, I can use any kind of logical operator here. So if I say this, x not equal to y, well, this becomes true because x is true, and then we have 3, and x is not equal to y. And what do you think if this statement is true or not? Well, this is actually true because x is not equal to y, because this is not, y is not 2. And then because it's true, it will go and print this line. So let's go and try running the code again. And this time we get to see x is not equal to y. So we understood if statement and why we need to use else. So for example, let's just, comment this out. Okay, let's just say we don't have else block. I'm going to save the file and run the code. Now you can see else is equal to y. Well, basically it's actually true. That's why we got this printed. So now if I say x equal to y and run the code, I won't see anything getting printed. No code was executed which could print something onto the console because we didn't have anything. If this becomes false or if this becomes true, we print. If it becomes false, we're not going to do anything because we don't have else block. So this is why we needed to use else keyword, and this is the syntax using else with if. Now another scenario sometimes occurs in programming when you have to check for multiple conditions. So let's just say here we're using if and else, but let's just say we have another variable. So I'm going to create a variable called z, and I'll just say 5. Okay. Now I will create another condition within if and else, and the way we do that is by using else if keyword, and then we have parentheses and then the code block. Okay, similar with if, but you add else before if. Now here in the condition, I am going to say if z equal to x plus y. Now we have a condition. I'm going to indent it. Now here it says if condition have an empty branch because it doesn't have anything to execute. So I'm going to say print ln, and I'll say z is equal to total of x and y. Now let's just say we have first condition, if x is equal to y, it will print out this one, and then it will go and check for this condition in case this if is false. Once it's false, it's going to check for this condition, and this is true, then it's going to print this line. Otherwise, it will go and print this line. So I will just change this to say no statement was true. Okay, so let's go and run the code. Once I run the code, it said z is equal to total of x and y. Well, if we say 2 and 3 equal to 5 when you add them, and then it basically becomes true because y plus x is 5 and then z is equal to 5 as well. So that's why it's printing this one. Now if I change this to something like 7 and now I run the code, I'm expecting this last statement to be printed. It says no statement was true. Let's recap what we have learned so far. So for example, I'm going to draw a line here. Okay, so here you have a line. Okay, you start from somewhere here. Here you have a condition, another condition, another condition, and another condition. So what will happen when the compiler comes to this bit, it will go and execute the condition here, and if the condition becomes true, so let me write that true here. If they become true, then what it will do, basically it will go and execute this condition code. Once the conditional code is executed, then it will go to the next else if and check for the condition. If that is true, then it will go execute another one and this code block will be executed. Then we have another else if it says, let's just say it's false. Okay, let me just write that. So we have a false here, and in terms of false, it will just go to this condition. Okay, and if this is false again, it will just use the else block. And if it doesn't have an else block, it's not going to execute anything. I know this diagram is a little bit weird, but I think it's nicer to recap what we have learned so far. So this is how we do a decision making in Groovy using if, else if, and else. This concept in decision making we're going to learn is a switch statement. A switch statement is pretty common as well, and it's found in pretty much all the programming languages. Syntax is pretty simple as well. You start with the switch keyword, you give an expression, start with the code block, and then you define a case by starting with the keyword case, and then you use this colon to actually finish that case condition, and then you run the statement. And we also have a default. So let's take that is this is like your else if. Okay, this is your else if, this is your else if, and then default is like your else. Okay, also we have a couple other things like break. Now, before we get to the code, let's take a look at this diagram. And this diagram will basically telling us here we have an expression. We get to this, we have a case 1 and a code block. So let's just say if the case 1 becomes true, then it will run the code and then it will go to the next case. If that's true, it will run the code, it will go to the next case and then the next case. Okay, if none of the case is true, then it will go and run the default, which is like like else in if that we were already seen in the last video. So given an example, it's pretty simple. Okay, let's go here. I have actually commented this code, so don't worry about these 3 dots. IntelliJ is pretty nice to actually just use these 3 dots to show that it's been commented. Variable, so just x equal to 5. All right, and I'm going to use a switch statement, and then expression is x, and then within that I'm going to start by using case. I'm actually going to start the code block. Okay, now when we have a case, I'll define 1 colon, and then I'll define the println, and I'll say x equal to 1. Okay, and then every case has to have an exit loop keyword, which is break in this case. I'm going to define a couple more cases here. So what I'm going to do is paste the code instead of just typing and wasting your time. So here we have 6 cases. So I'll say if x would be 1, then it will print this line. Otherwise, it will go and check for the next case. And any case that becomes true, it will print its statement and it will break out from the loop. We haven't talked about loop, but don't worry, next video we'll talk about loops as well. So basically, the statement is like running each case and doing over and over until it matches the condition. Otherwise, if there's no condition matched, then it will go and execute the default. So default keyword is used within the switch statement. It's like an else block in if and else statement. It's pretty common. So I'm gonna save the file and I'm gonna run the code. And here it should say x is equal to 5, which is basically true. So if I change this x value to 1, and then if I just run the code, it will say x equal to 1. Okay, so now next thing we want to do is we are going to change the value to, let's say, 9, and we know that there is no case that exists as 9. So what it will do, it will run the code, but it will go to the default block. So I'm gonna just run the code, and here it says no statement was running. Okay, sorry, not state, no case was valid. No case was valid. So this is how we use switch statement to write cases. It's a little bit better than using if statement if you only have to use one condition. Let's talk about loops in Groovy. So far, we've seen statements which have been executed one after another in a sequential manner. Additionally, statements are provided in Groovy to alter the flow of control in a program logic, and they are often then classified into flow of control statements. Now we got 3 types of loop statements in Groovy. So we got while statement, for statement, for in statement. We're going to start by looking at while statement. So while statement is executed by after evaluating the condition expression which returns a boolean, and if the result is true, then the statement in the while loop are executed. To discuss loop, what is a loop in programming language? Well, a loop in general, not in programming language, it's something that you repeat over and over until one condition is fulfilled. Similarly, in programming, you repeat a code block over and over until the condition is over. So let's visualize our example in a whiteboard. So let's just say you have x, which has a value of 1, and you want to assign a value 10 to x. But there's only one condition. You can only add 1 to x every time you run the code. So the way we can add value 10 is by running our code 10 times. So what it will look like in a code, we will keep our code running until the value becomes 10. So in a while loop, let's just I'm gonna write the pseudocode. So we'll just say while x is less than 10, then keep adding 1 to x. Okay, so you're gonna have to write down this in a code. This is like a simple English, but in a code it will be, using a while statement. So let's go and do that. I'm going to first of all clear our example, and I'm going to start by defining an int x equal to 1, and I'm going to start by using while statement, and the logic would be x less than 10. Then what it's supposed to do, it's going to first of all print ln, and I'm going to just print the value of x, the current value, and then we do x plus plus. Okay, so every time it's going to run the loop, it is going to print the value of x, so we know that it was incremented, and then it will add the value of 1 to x, and then once it reaches to 10, well, logic says less than, so the value would be up to 9. So I'm going to run this bit. First of all, let's write this with type Groovy source loops, enter, and then you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so as you can see, what happened here is it ran this logic 10 times. So it started from a value 1 and then 2, 3, 4, 5, 6, 7, 8, 9. I mentioned that it ran our while loop 10 times. The reason for that is the 10th time when it ran, it find out that this condition is no longer valid and it returned false. That's why it wouldn't go inside the code block and print the value of x. So that's why here we got 1 to 9. Let me just clear this. So we've got printed 1 to 9, which is correct. Now the next statement that we're going to look at in Groovy is going to be for loop statement. So here we got for loop statement, which is very, very important because this is the statement that you're going to be using a lot compared to while loop. So let's take a look at the building block of for statement. First of all, here is an example. So what we have here is a variable declaration, an expression, and increment. And then we got this statement that we can write in the code block. So what is a variable declaration? So this step is executed only once for the entire loop and used to declare any variable which will be used within the loop. Expression will consist of an expression which will be evaluated for each iteration of the loop. So this is like a condition that you define here. This has to be fulfilled before it can, keep iterating. The increment section will contain the logic needed to increment the variable declaration for increment. Now the diagram that we have here is for loop is here. So what is this? For, and, condition, increment, and then conditional code. So here's a diagram. So you start by giving a condition, and then if the condition is true, it's going to run the code block, and it's going to go back and execute that condition again. So it's pretty common in pretty much all the programming language, and every time the condition becomes false, it will just break out from the loop and execute the rest of the code. So here is a basic example of a for loop, and if you want to print out 1 to 9, this is how you're gonna do it. Back to IntelliJ, and let's try it out. I'm gonna clear this out. Not gonna remove it, but I'm just gonna leave that here commented. And I'm just gonna, use the IntelliJ feature to actually hide that. All right, we don't really need this bit as well, so I'm just gonna hide that part as well. Now what we need is for loop. So we start by defining a keyword for, use parentheses, and the first thing we need to define is a variable declaration. So we can say int x equal to 1. Okay. And then the next one is going to be our expression. So that's going to take a semicolon, and expression is going to be something that has to keep the logic for iterating. So we can say x less than 10, x plus plus. Okay, so let me go and explain this to you. Very, very simple. Not really, hard or not something going on here. So this one is our variable declaration. So we're defining a variable within the loop. So we're saying int x is equal to 1. Okay, that makes sense. Next, we have this x less than 10. This is our condition. So basically, it's going to tell the compiler, hey, keep running this loop until x is greater than 10. And we need to make sure that we get to some point where we get out from the loop. So if I say x equal to something like 1 or 2, now the x is never going to be a greater than 10, and this will become an infinite loop which will never be stopped, and that can cause a lot of issues. So you need to make sure that when you run a loop, you need to break out of it. To be able to break out of it, you need to have some sort of logic. Okay, so here I'm going to write some println. So let's just do something like print ln, and I'm gonna just do a print x, okay? And let's go and run this file. Once I run this, it gives me the same sort of result here, 1 to 9. All right, let's just close this part. Now, as you can see that we simply ran our loop up to the 10 times given this logic. So that's a different way of defining loop. So it basically, the difference between while loop is that while loop checks for the condition before it iterates over. This loop will iterate for the first time and then check for the condition. Next statement we're going to take a look at is for in statement in Groovy. I'm going to read this line here. It says, the for in statement is used to recreate through a set of values, and the set of values are basically our data type, which we haven't actually talked about. You might have heard array in any other programming language if you're familiar with. So arrays are basically created in square brackets, and then you start by defining a value separated with comma. It's pretty simple. So you can define the type as well. So if you want to iterate our array depending on the values it has, you can do that by using this for in statement. So let's go to the code and we're going to use for in statement. First of all, let's define an array. Okay, so I'm going to use int type for array. I'm going to just define a value x, and the array is defined within square brackets, and the values are separated with comma. So we're just going to do 1, comma, 2, comma, 3, comma, 4, comma, 5, 6, 7, 8, 9. All right, so we got a value x. I'm gonna just comment this bit out as well. So let's make some space. All right, so we got an array x. I'm going to loop through this array. So it's got 9 values, which means it's going to loop through 9 times. So what I'm gonna do here is use for in statement, and IntelliJ is smart enough. It basically gives me this, a boilerplate code. So I'll say x in range, which is our x, and I'm gonna just choose I. I defines an index, and then it's saying, hey, can you grab every time a value from x index and then just loop through and put that index here. So if I do something like print ln I, and then print, actually we can add that x as well here, I, and then we can also add empty space and then plus x. Okay, let's run this code and see what happens. All right, there we go. So it ran 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And then also because the value of x that we keep printing, this is going to give you like this kind of like an output. So basically you can loop through a certain range that is defined in an array. Okay, so it doesn't matter if it's like a value in string. So if I do x, or I do something like d, now there's going to be a problem because we have specified here, type int. Now to be able to get that, I'm going to just remove the type. Okay, and define here def x. Okay, and then let's run the code again. And there you go. It's 1, 2, 3, x, d, 6, 7, 8, 9. So it still, printed out our values. So at this stage, we've covered all 3 types of loops provided in Groovy. We'll take a look at how we can use this loop in the rest of the course. Welcome back. In this video, we're going to talk about methods in Groovy. So let me read this paragraph here. So a method in Groovy is defined with the return type or with the def keyword. Method can receive any number of arguments. It's not necessary that the types are explicitly defined when defining the arguments. Modifiers such as public, private, and protected can be added by default if no visibility provider or modifier is provided. The method is public. Now, what is a method? Well, we've already seen a lot of times this main method. Okay, I mentioned in the start of the course that we will talk about methods later in the course, and this is the video for that. And methods are very important topic. Methods are used pretty much everywhere in your programming, and they're pretty much used in every part of your application development. So you need to understand how to use methods, how they're used, and why do we need them. Now this is a simplest type of method. So here we got def keyword, a method name, followed by parentheses and curly brackets. Well, curly brackets, I usually call them code blocks, which is like, if you have a opening and closing curly brackets, that's like, code that you can type. So this is a very simple method. Now, given the example we have here, I am going to create a new file in IntelliJ. So let's go and create new file. I'm going to right click on source and click on Groovy class. I will name it a method. Okay, so here we got a class, but we need to create a method. Every Groovy application requires a main method. Similarly, Java application requires a main method as well. So the way you do that is by static void main, and that will just be a string for array args. I'm gonna and then the code block, which is opening curly brackets and closing. Now, this is the main method. Okay, we are not going to use this main method as our example because we're trying to understand what methods are and what they can actually do for us. So first of all, let's go back to the article. Here we've already seen a simple example. Okay, that's the method. And then we have another example here. This is a little bit weird, so I'll use rectangle. Okay, so we got class, we got def display name, and then you have this print line functions there. Let's go and create a new method. I'm going to start by using a def keyword, and I'm going to create a method with the name display name, followed by parentheses, and then the code block. Okay, in the code block, we are going to simply use a println and just say, now to be able to use this method, you need to invoke it. And the way you invoke it is by specifying the name of the method. So here we got display name followed by parentheses. And if I run this code now, let's go type groovy source/method.groovy file. We got errors. The program didn't run. So let's say, what is an error? It says cat groovy.lang missing a method exception, no signal of method static. So basically in Groovy and in many other programming languages, there's a concept called scope. So in the main method that we are invoking, this display method, we basically don't know outside of a main method. Let me give you an example how this works in terms of scope. So let's go to whiteboard, and here I am going to draw two boxes. Okay, so here is a box for our main method, and then we have another box called display name. Okay, so they have their own scope. This main method does not know that this display name actually exists. So to be able to use this display name method inside this main method, you need to tell that this exists, and you need to make this display name method available to the outside world. And the way we do that is by adding a static keyword when you're declaring this method. So when you have this static keyword, it will basically let main method use inside that. So I'm gonna just use this arrow here, and just to visualize, once you have the static keyword added, when you are declaring this display name method, it'll basically make it available to the outside world. So let's go to our code. I'm going to add this static keyword there. And now IntelliJ removes that warning. And now if I run the code, you'll see hi there is getting printed. There we go. I'm still using that bait, but it's fine. Okay, hi there. All right, so this is how you make this method available in main method. Now I'm gonna try creating another method which will be more interesting. So the method we're gonna be creating is going to help us add numbers. So for example, here is a box. Okay, let's just say here's a method. Okay, it's like a machine. I'm going to name this add numbers. But what numbers are we talking about? We need to put numbers inside the method, process their addition, and return the result. So the way you can do that is by, let me just draw some arrows here. So you're gonna put numbers, okay? You're gonna process the numbers here, whatever the process that require, the logic will be inside the function, and then you're going to get it out from the function. Okay, so this is how it's gonna work. To be able to put numbers, we call them parameters. So the way we define a parameter is by adding in the parentheses. I'm going to remove this display name method. We're gonna have to remove that here as well. Now let's create a new method. So we're gonna use a static keyword def, and we're going to name it add numbers, and that's our code block. Okay, to be able to put the numbers within this add number method, we need to have some parameter, and we can even define the type of the parameter. So I'm going to use int x comma int y, and what we need is we need to add x and y. Okay, now we need to add x and y and then return the result out of this function as well. Here you see there is something called void. A void is basically a return type, which basically equal to undefined or null, which means it's not going to return anything. So we can type void here just after that, and now it's will not return anything. So now if I use a return keyword x plus y, it's gonna throw an error. It says cannot return an object from a method that returns void. So that's a problem. So here we are explicitly defining the type that is going to be returned, which is going to be integer. So I'll just type int. Now the error goes away. I'm going to use this method inside the main method. So I'll call it by add numbers, and I'm going to define some values for x and y. So I'll just do 10 comma 20. Okay, now it's going to return the result, but to be able to show the result into the console, we need to use println. A println itself is a method which is built into Groovy. So now if I run this code, you'll see 30 as a result. So let's just clean this up, and we have 30 here. Okay, so now our function is working. And what is the benefit of creating this method instead of just adding these numbers? Now let's just say you want to add numbers many times in your application. Like there are like 50 times that you have to add x and y or any two numbers. Now you will have to write this x and y again, x plus y, again and again in many times in many places. To avoid that, you can create this boilerplate or we can call it like a machine that you design, and its job is to just add number, and you can reuse it anywhere you want in your application code. So I'm going to use this line and duplicate it. So let's just do a duplication of this. Now I'm gonna just run the code, and you'll see 30, 30, 30. Now let's go and change some values. I want to change this to 50, 20, and then let's just do 0, and we are going to do like 2. That would be like 13 and 14, just the random numbers. I'm just gonna get rid of a few lines here. Okay, so now you can see that we're using this add number method like 4 times with different values. And we're gonna get the result in the console for each of the execution. So the first execution returned 30, and then 70, and then we have 2, and then 27. Okay, take a look at a few other things within method. Now we have a method parameters that we have already seen how we define those. I'm just gonna read some of the stuff from here. So it says a method is more generally useful if its behavior is determined by the value or one or more parameters. We can transfer values to the called method using method parameters, and that's what we've seen. The simplest type of method with parameter is basically like this. We have a method name, parameter 2, parameter 3, and then the code which goes here. Also, we have some other things like, a default parameters. So what is a default parameter? Well, the concept is pretty simple. A default parameter is something that will have a default value if the value is not defined. So if I go back to the code, and let's just say if I don't define a value for y, I'm gonna get an error. It's giving me a warning. It says add number in method cannot be applied to java.lang.integer. The reason for that is this requires 2 parameters, as you can see here, x and y. So if we don't provide 2 values to it with its type defined here at the time of calling it, it will throw an error. To be able to fix this, or to make it basically, make sure there is some sort of default value for these parameters, you can assign them right here. So if I do equal to 0 and then equal to 0. Okay, now let me just comment this bit for now. All right, I'm gonna go and clear the terminal, and I'm going to run the code. Now what is you going to expect from this line? Well, it's going to basically apply the value of 10 to this x, but when it comes to y, we haven't defined any value. Because we haven't defined any value here, it is going to use the value 0, which is a default value for a parameter. So let's go and run this code. I'm going to press return in the terminal, and you get to see 10. If I define a value 2 here and save the file and run the code, you're going to get 12, because that's the default value. Now let's just say I go back to the function, press a comma, and I will define a value of like 5. Now as you can see here, we are defining a value for both x and y. Now in this case, when we define the value of both x and y at the time of calling this function, it is going to use the value which we have defined instead of the default values. So I'm going to run this code, and it's going to give me 15. So it's ignoring the default values that we have, specified. Now, because we have set the default value for both x and y, I'm actually going to get rid of both x and y value from, function call. And I'm going to run the code now. What value are you going to be expecting? I expect 2, because 0 plus 2 is 2. And that's what we're getting here. All right, so let's go back to our article. So that's what it's saying. This is also provision in Groovy to specify the default values for the parameters in the method. So if no value are passed to the method of the parameter, the default ones are used, and we have we looked at the example for that as well. Now, another concept is return values that we've already seen. What we need to use is a return keyword to be able to return the value. Now, when you say I'm returning C, you can specify its type within the function, or when you are putting it outside, you can specify its type here as well. Next concept that we have seen, instance method as well. So instance methods normally implemented inside classes within the Groovy, just like Java. And a class is nothing but a blueprint for creating a different object which defines its properties and behaviors. We have not looked at the class, so I'm going to skip this concept for now. When we look at classes in Groovy, which is a very common concept in all object-oriented programming languages like in Java and stuff, we're going to have to, talk about instance method. Next, we talk about local and external parameter names. I've already spoken about the scope in Groovy, and this concept is pretty common in other programming languages as well. For example, let's take a look at this example. So here we got public int getX, and it returns a value of x. Now, if you take a look at here, the x is actually defined outside the method. It's not defined inside the method. So how come this getX function know about x in the global scope? So there's a local scope and there's a global scope in Groovy and in many other programming languages. So what we can do here is we can actually access to a global property. I'm actually going to read this paragraph here so it will make you understand. Groovy provides the facility, just like Java, to have a local and global parameters. Now, in the following example, which is given down below, Alex is a local parameter which has a scope only within the function of getX, and X is a global property which can be accessed inside the entire example. So here is an example. Let's take a look at in our code. So let's get rid of some of the code from here. I'm going to do a bit of a cleanup. Let's get rid of this. Okay. Now I'm going to define a variable, a static, and I'll just say a equal to 5. Okay. And then I'm going to get rid of this function as well. So I'm going to create a function which we can call it public. It's going to return int, and I'll just say get number, and then we are going to just use a code block here, and I'm going to create a variable. Let's just say int x equal to 5. Oh, maybe let's change the value to 10. Okay, then I'm going to say return x plus a. Okay, and let's call this function in our main method. So I'm going to say get number and just run this. Still, we're missing this static. So I'm just going to, use a static keyword there and run the code. Now, as you can see, it ran the code, but it didn't, print out anything. So we just gotta do a print ln, save the file, and then run it again, and then we should see 15. Now what's happening here is that we got the integer created in this getNumber function, which is named as x. Now we can basically access a, which is outside, but what if you want to access this x inside the main method? So I'm going to use print ln, and I'm going to first print a, and we'll use print ln, and I'm going to print x. Now this thing is defined within the function, this one, and then here is defined outside the function. So even if I do a static keyword, which is actually not allowed within the function, so it says variable cannot have modifier static. Okay, So if I run this code, it's going to throw an error. It says this X it doesn't know about. So this function has its own scope. Okay, it will not allow anybody to access the parameters or variables defined within the function, but it has access to the values or variables defined in a global scope. So this is like a global scope. When you define a function, it has its own local scope. Anything that you want to access within a function, you can access from a global scope, but you can't access from a local scope of a method. File equal to new file, which is coming from Groovy, and then we define a path and then the file name hello.txt, and then I'm going to just finish this line. Now we're going to write something to it. What we can do is call the file dot write method on it and give it the content. So I'm going to say hello world. Let's save the file and let's run it in the terminal. So I'm going to go and run Groovy space source file IO, and I'm going to bring the Explorer up so we can see the file will be created. Press return, and then you will see a new file hello. And if I open that file, you'll see we have a hello world. Quickly go over what we have written. So we got a file, and this is a type that we're defining for this variable file. And we're saying, okay, I'm going to use the assignment operator, and then I'm going to use this new keyword, which will help me to create a new object from file. Then this is basically a new instance of the file. This will require a few things. We've already seen that, but I'm just simply defining here a path. In Linux and Mac OS, if you type /, that means you're targeting the current directory. If you're in Windows, don't worry, we will learn how to access current directory that you're in by Groovy in a bit. Child is basically the name of the file that you're trying to create, and then we're using this file method and we're calling this a write method on the file, which will help us to write content to the file, which is hello world. We're able to create file using this code, but this is not the best way to create files. The best way to create file is by creating a method which will help us create file and also will help us to handle any kind of exception that we get when we create this new file. So we're going to create a new method. I'm going to start by using a static keyword. I'm going to say void. I don't want it to return anything. And then we'll just say create file. Okay, that's the name of the method that I'm creating. Then use parentheses. And what we need to give this function is a path, a child, and a content to write. So we can use those as arguments. So I'm going to start by defining a type of an argument, which would be path, comma, and then string, file name, string, content. Okay. Next, we are going to create a logic. Now, we know that we can create a new file by using this line. So let's copy this bit. Let's cut it actually, not copy, and paste it here. And I'm going to just cut that and then paste that here as well. So first of all, we need to change this to say path. And then child would be file name. Then the content that we can write, we want to change the hello world to content. Now let's just say that you're using this file object to create a new file, and for some reason, God knows why, but for some reason we get an exception, which means we get an error. Somehow Groovy is not able to create a file. But how do we want to catch that? How do we want to make sure that the program doesn't break? It will continue running, but it will just throw an exception. So what I'm going to do is use try catch block. Try and catch are keywords that represents the handling of exception due to data or coding error during program execution. A try block is a block of the code in which exception occurs, and a catch block catches and handles the try block exception. In this case, as we can see here, we got the try block. Okay, and then we got a catch block. So whatever happens here, if there is an error, that will be passed into catch block. Try-catch statements is used in many programming languages, including C, C++, C#, Java, JavaScript. It is available in pretty much all the programming languages. I haven't come across any programming language which does not have a try and catch block. Try-catch block basically will allow us to run a block of code. If there is an exception thrown from that, it will be cached. Now, if we don't do that, our program will break and we won't know why it is broken. And also, it's better to cache those errors and sometimes maybe ignore them so your program's running without that part of application. Try our newly created function called createFile, which will help us to create new files. I'm going to go to the File Explorer and delete hello.txt file. And also I'm going to go open terminal. I'm going to run this code. But before I do that, I need to use this function to create a file. So let's do that. Our main method, I'm going to start by using createFile function, and it will require three things: the path, file name, content. For the path, I'm going to simply use /file name. Let's create hello.txt file, and then the content we can just write hello world. Okay. I'm going to go and open the project browser, and I can see there's no file called hello.txt file. Let's close that and then open terminal. I'm going to run this command, which will run our code. In the project explorer, we can see we have a file hello.txt, which has a content of hello world. Now we know how we can create files using our newly created createFile function. We are going to start by creating a new function which will help us reading files. In the article, we have reading files. The following example will output all the lines of text in Groovy. The method each line is built into the file class in the Groovy for purpose of ensuring that each line of text is read. So here is an example. So we got new file, that's what we're creating, and we're using .each line, and we can just print ln every line. We can also read the content of a file as an entire string using this file.text property. So let's go back to our code and let's do that. So we got the file path, and I'm going to simply use that file to read it. First of all, let's just use, in the code, we are going to start by using file, and I'm going to say file equal to new file, and then that would be path. Okay, we're going to use try catch block again, so we don't have any problems later. And I'm going to cut this line and paste that here. Then I'm going to just use ZE. Right, so we got the file, then I'm going to do file.text. We create a function, we can also return the text that is read from the file. So we use the return keyword and we change the return type to string. I commented that line which was used to use the create file function. We're going to start by reading file by using read file function. We need to define the path for the file, and we used create file to create a hello.txt file earlier. We used the same file to read content from it. Let's use a def keyword, name the variable read file, and then set that equal to read file, and then the path in the parentheses. Type read file. So the content will be read by using this read file function, and the content we are returning from it is going to be stored into read file variable, and that's what we're printing. I'm going to save the file and open terminal. I'm going to run the code, and you should see hello world will be printed in the terminal, and that's what the content that we have here. So might be confused about this read file variable versus this read file variable. So what I'm going to do is rename this to read content, and we're going to change that to read content as well. Also, I'm going to go to hello.txt file and just add some more text to it. Okay, let's save that hello.txt file. Now, if I run the code, I should be able to print out all the content from hello.txt file. So let's do that. And there we go. We got all the content. To open hello.txt file, and remove this gibberish that I added. Let's learn how we can write content to the file which already there, such as hello.txt file. Let's close this and let's try writing a new line to hello.txt file. I'm going to close the terminal and I'm going to create another function. Let's start by defining static, and that should return nothing. And we just say write content. And that will require a path to the file. Then we have a content to write, which will be a type of string again. So what we're doing here is we are creating a new instance of a file with that particular path. Then we're using that file and we're calling this method with writer, and we're using writer property of that, and then we're calling this write line function, passing the value that we want to write to the file. So now let's go into main method. First of all, let's comment this out and comment this out as well. So let's start by using write content method, and the file that we are going to be using would be hello.txt file slash hello.txt file, and then content we want to write would be hello world 2. Remove that from here. Instead, I'm going to use a variable content. Let's save the file. Now, once we have written this successfully, then what we need to do is read that file. So I'm going to cut this code and then paste into the next line and uncomment these two lines. Now let's go to the terminal and try running this. First of all, let's verify this hello.txt file is basically doesn't have hello world 2. So let's go and run the file and we should be able to see hello world 2. Let's go to hello.txt file and you can see we have the file with hello world 2 content in it. Talk about how do we get the size of the file that we are working with. You can get the size of the file using the length property of the file class to get the size of the file in bytes. So I'm going to comment these 3 lines and we are going to create a new file, and then we're going to pass in ./hello.txt. So I'm going to try finding what is the size of this file in bytes. So we can do println, use double quotes, and then I'm going to say the file size is, we can use $, and then I'm going to use file.length property. We can use bytes here. So let's run this line of code. And we can see this file size is 13 bytes. So if I go and open this in a Finder, and I'm going to right click and then say get information, and you can see it says 13 bytes. This is the size of the file. Next, we take a look at how do we find out if we are working with the file or with the directory. You can do that by using isFile and isDirectory option of a file class. So let's get rid of this code. We don't really need that. Let's save the file, and now I'm going to go and do a println. We can say file.isFile. Save the file. Let's get rid of this line as well, and I'm going to do println file.isDirectory. Pretty simple, easy to use functions which will help us to figure out if this is the file or if this is a directory. So as you can see here, it says true for the file. So let's just wrap that here. So say is file, and then we're going to change this to is directory. And let's go and let me actually go and give a space here. And now let's run the code again, and we should see is directory true. Sorry, not directory, but file is true, and is directory is set to false. So that's good. I'm going to change this path name to just dot slash and save the file and run it. And this time, because we are targeting a directory, it should say is directory set to true and is file is false. So that's all right. Now we can, figure out whether we're working with the file or with the directory. Also create directories using file class. I'm going to comment these two println statements, and I'm going to create a new directory. We can call it test. So first of all, let's go and do the code file.make directory, and then I'm going to pass that test. Okay, let's run this file, and we should be able to see a new directory created here called test. There you go. So we got a test directory created for us. Now let's say that we change this test to hello.txt, and there is a file called hello.txt file. So I'm going to save and run the code, and now let's see what happens. Well, it wouldn't do anything because we're not even working with the directory, we're working with the file, and that would not create the directory for us. The way we want to handle this kind of situation is by making sure that we are working with a directory. So let's go and write an if condition there. So first of all, let's get rid of this line. I'm going to say if file.isDirectory. If that's the directory that we're already working with, then we don't want to create that new directory, right? So we can say if not, let me just add this negate statement. If that's the case, then what we want to do is create a new directory. So we can use file.mkdir, and that will create a new directory because we're working with the file. So I'm going to just briefly change this to hello. Otherwise, I would like to just print ln, and we can just say directory not created for now. Let's run this code. So the code ran, and then we get to see this hello directory. Now if I just go and run this line of code again, and we should see directory not created. The reason for that, directory exists and it came as true, and we're using this negate to be able to say, hey, if there's no directory with this name, then go ahead and create a directory. We can also delete files and directories using Groovy. So I'm going to just comment this if and else block for now, and we're going to use file.delete. Simple function, save the file and run the code. Now you will notice that we have this hello directory. It won't be available any longer. So if I run the code, that hello will be gone. So that means we deleted the directory. Now let's just say I want to delete this test directory. So we'll just do test, and then I'm going to just run the code, and that test will be gone as well. So if I create a new file, for example, I'll go right click. Actually, let's do that here. So let's create a new file, hello.txt, and we get the new file in the source. I'm going to go back and then change this to src/hello.txt file. So I'm going to delete this file now. Let's run the code, and you should see hello file is deleted. So delete function deletes directories and files. Pretty simple. Next operation that we want to talk about is copying files. Groovy also provides the functionality to copy the content from one file to another. And copying files, it is a pretty common operation that we do on a daily basis when using computer. So I think I'm gonna remove all of these content. Perform copy operation using computer. What we do is we copy a content from one file and paste the content to another file. So we're going to need two files. So I'm going to start by using file, and I'm going to say f1 equal to new file, and we are going to use this file to copy the content from. So I'll do src operators.groovy. I want to make sure that I write the proper spelling so it doesn't, cause an issue. So operators, yep, this is the file that we're going to be using to copy content from. All of this will be copied. And then where we want to copy is going to be a new file. We call it, let's just say this equal to new file. and then we are going to just create a new file if it doesn't exist. So I'm going to say hello.groovy. Okay, I want to change name this to, let's just say, file. Simple. Keep it simple. Simple is better than complex. Where we copy and paste, we will use this operator. So we are going to use this where we want to paste the content. I'm going to use this operator, and then we're going to say file.text. So what it's going to do is going to take the content from this, which is the text, and then paste that into this file. Now let's go and run the code, and now we should see hello.groovy with the same content. And let's just say that you want to copy 1,000 files one by one and make a copy of those. If you want to do that with Finder or Explorer on Windows, that would take hours. Instead, you can write a script which will do that for you automatically. Welcome to this section of the course in which we are going to talk about data types into details. So far, in the last section, we have seen the basic syntax of Groovy programming language. We also talked about decision-making loops, variables. Now we're going to take that knowledge and apply that in this section. We're going to go dive deep into data types. In terms of data types, we've already seen numbers, strings, arrays, but we're going to go and dive deep into these data types. We talk about what are the built-in methods available for each of these data types. We talk about numbers methods, strings methods, map, and list. There's a lot to cover in this section. I'm really excited. So without further ado, let's get started. In this video, we are going to take a look at numbers methods provided by Groovy. We've already seen what is a number. We talked about integer versus floating numbers. The focus would be working with numbers method and what are the benefits they provide us. So let's go to article. So here in Groovy, numbers are represented as objects, and all of them an instance of a class integer. Now we're gonna go down, and then we have numbers methods. Here's a list of numbers methods. So first of all, let's go back to IntelliJ. I'm going to go and create a new class file. I'm gonna name it numbers, enter, and we have a class numbers. I'm going to paste this code which has a numbers as a class and a static method named main, and we also know that main method is required to run Groovy program. So let's start by using integer as a type, x equal to, let's just say 5, and we're going to do another integer, y equal to 5. First method we're going to talk about is going to be compare to. Let's just say that you are going to compare x to y. You can do that by using equal to, which is a logical operator that will return you true or false. But numbers class provide a special method called compare to, which we can use to compare to integer. Let's take a look at how we do that. Keep the println there so we can log the output. I'm going to use x dot, and now we get all the methods that are available. IntelliJ provide really great IntelliSense. Once you want to pop up this box, you can press Control Space, and that gives you suggestions for all the methods available of the specific class that you're trying to access for. Now let's do a compare to and put in y as in parentheses. Once I run the code, I get to see 0. Why did we get 0 instead of Boolean like true or false? I'm pretty sure that's what you were expecting, but that's not the case here. The compare to method will return 0 if the values of both integers are equal to each other. That will return 0. And as you can see, x has a value of 5 and y has a value of 5 as well, which means they are equal to each other. That means we are getting 0. Now if I change the value of x, let's just say 6, I'm going to save the file. I'm going to expect 1 to be returned. There we go. So what's happening here? Well, there are 3 cases here. If the integer is equal to argument, then 0 is returned. If the integer is less than argument, then -1 is returned. If the integer is greater than argument, then 1 is returned. To change that value of x to 4, now x is actually less than y. So what we're expecting here we expect -1. Instead of checking for true and false, you can check for if they're equal, and if it's not 0, that means they're not equal, okay? And if they are, equal, then you will get 0, which you can, do your logic with 0 or non-zero value as well. So it provides us three things. We're going to see some other methods in numbers. For example, equals. Equals method determines whether the number object that invoked method is equal to the object. Similarly, like this. So instead of compare to that you can use to do that, you can use directly equal. So if I run the code, I should get false now because they're not equal. So if you're interested in getting Boolean, method is available for you. So I'm going to change that x value to 5 and run the code. Now we expect true to be returned. There we go. This method we are going to take a look at is going to be value of. Value of method returns the relevant number object holding the value of argument passed in. This method is static. So here we got x variable which has a value of 5. We're going to use x to create another variable which will have a value of x. In this case is going to be 5. So let's go and create a new integer. I'm going to name it z equal to, and then we use integer dot value of x. I'm going to use println. I'm just going to print z. Now let's run this code and I will expect z will have a value 5. About two more methods in numbers, which is going to be parseInt and toString. They're pretty much simple thing they do. So we have a variable y. I'm going to change its value from integer 5 to string 5. And we're going to have to change the integer to string. And the warning will go away. So IntelliJ was giving us warning because it's saying that, hey, you cannot assign string to integer. So that's fine. I'm going to get rid of these two lines. And now if we want to convert this y into a number type or integer type, we can use parseInt method. Create another integer. So type int. You can define integer type just like typing integer with the full word. You can just use int as well. So I'm going to use a variable name as, let's just say z equal to, and parseInt is a static method, so you can call it on integer class, and we can use that variable parseInt, and we can pass in y. Let's do a println z, and let's run the code. Now the value returned would be 5. If I print out a value of y and run the code, let's see what happens. So we get 5 of 5, but y has a type of string and z has a type of integer. So in program language, when you're working with, especially with APIs, you usually get string with long numbers, okay? And this method comes in handy if you want to convert that into, number type. Now we have another method called toString, which can be used to actually, convert the integer to string. So if I change that integer to toString, y is already string, so it's going to give us the warning, it says toString in Java.lang cannot be applied to string. So what we need to do is we need to change that variable from y to x. Now in this case, we are converting integer x to actually string. So here it's going to throw a warning because we specifically defined the types. We're just going to use def. Let's run the code. And now we're converting this x into string type by using toString. Let's go to an article that we were going through, and here we have a list of methods available. Now, I don't want to go into every single method and show you what it does. You can go through this. You will find a link to this article in the description of this video or in the notes. So you can click on that link and go to this particular method list, and then you can read about what it does. For example, floor. If you know a bit of basic math, then you know what the floor is in basic mathematics. So method floor gives the largest integer that is less than or equal to the argument. Ceil, the method gives the smallest integer that is greater than or equal to the argument. We have an ABS, we have a parseInt that we've seen. toString that we've seen. So we know how do we use the method on integer. I would highly recommend you go through these methods, apply them, and try to use them. One of them is round, which is very commonly used, and it rounds the number to the closest longer integer. If you know basic math, you know what round means in basic mathematics. I would highly recommend go through this article and have a look at what is available to you. Welcome back. In this video, we are going to talk about strings in details in Groovy. We've already seen how to create strings. You wrap strings or characters or paragraph in single quote or double quote, or you can do even double quotes if you want to put single quote within the string. So I'm going to read this paragraph. Groovy offers a variety of ways to denote a string literal. Strings in Groovy can be enclosed in a single quote, double quote, or even triple quotes. What is a triple quote string going to do? Well, string with triple quotes may span to the multiple lines. We have an example here where we have a single quote string, double quote string. We use double quote string if you want to put a single quote string in the string. We are printing all three, and then we get to see these values. Now, strings basically used everywhere in programming languages, and when you're working with applications like mobile application or web application, strings are pretty much everywhere. This is the type of data that you pretty much consume most of the time when you are on a computer. So there are methods available for strings. We have a center method compared to ignore case, concat, each, match, ends with, equal ignore case, get add, index of. So there's a lot of methods available. We're going to take a look at some of them, and I would highly recommend after you know how to apply a method to your string, go to this article and then take a look at the method available to you. So let's go back to IntelliJ. I'm going to create a new file. So let's right click on the source, and I'm going to choose Groovy class and I'm going to name it strings. So let's create a string. So we'll use a string as a type. I'm going to use x equal to hello world. Okay, we got the string. Now let's go back to article and let's take a look at one of the method, which is to uppercase and to lowercase. These are very common methods. So what it does, it converts all the character in the string to uppercase. Next we have a to lowercase. It converts all the string characters to a lowercase. Okay, so let's do another string, and I'm going to use single quote but all caps. All right, so now let's clear the terminal. I'm going to go and use one of the methods. First of all, I'm going to convert x value to uppercase and y value to lowercase. First of all, let's do println x, println y, and I'm going to run this file, and you'll see we have hello world in lowercase and hello there in uppercase. So if I change that dot to uppercase, okay, save, run it again, and you see hello world will be uppercase. There we go. We can change this y to lowercase, and then if I run the code now, it'll be lowercase. There we go. Very common operation that you do. Sometimes you want to make sure that all the data that you coming from back in API, it is lowercase, so you can use this method on a string. This method that I'm going to show you is going to be substring. It is another very common method that you're going to be using when you're working with Groovy. So let's go and give it a shot. So for example, we have a string hello world. How many characters are there? So we got 5 characters there, 6 one is space, and then another 5 characters. Strings are 0 index based, and substring method returns a new string which is a substring of a given value. So for example, we have x, and we have a value for x is set to hello world. Now from hello world, if you want to grab hello world and basically create a new string out of it, you can use a substring method. I'm going to get rid of y, and I'm also going to get rid of this println. Now I'm going to create a new string, so we'll just say string z equal to x dot substring. A substring method requires two things, starting index and ending index. Now, starting index would be 0, and ending index we can say 5. I'm going to print z, and let's run the file, and we should see hello printed in the console. There you go. Okay, so substring methods basically returns a new string depending on the index you give. So starting index and ending index. Next method we're going to talk about is going to be reverse. It's pretty simple. I'm going to just directly apply that on x. So let's type x dot reverse. It doesn't require any argument. I'm going to run the file, and it's going to return us DLROW or LLES. So what is this string? Well, it's basically reversing this string. You can use this reverse method to get that. You can do this manually as well by using a for loop, but given that we have a reverse method, you don't have to worry about that. Method we're going to take a look at is going to be another common one, which is going to be concat. This is concat. Save. There's an extra parentheses. We're going to have to get rid of it. I'm going to run the file, and you can see hello world. This is a concat. So concat method basically appends the given characters or given string to the end. So you can see x is basically concatenated with this is concat at the last. Okay, I would highly recommend to go through this list and take a look at what's available to you. Here we are going to take a look at list. We've already seen what is a list. List is a structure used to store a collection of data items. In Groovy, the list holds a sequence of object references. Object references in a list occupies a position in the sequence and are distinguished by the integer index. So here we have a list like 11, 12, 13, 14. We have a list of strings, Angular, Groovy, Java. We have a nested list where we can create a list as a part of the list. We have a Groovy 21, 21.3. So this is like a list of object references. We have an empty list as well. And here are some of the methods that are available to us. We're going to take a look at some of the methods like add, contains, and we have a pop, and we have sort method. So all of these methods are pretty useful. Let's go to IntelliJ. I'm going to create a new file here. I'm going to name it list. Now I'm going to create our common main method so we could run the code. So now let's define a list. So I'll use a class list, and I will just say x equal to and 1, 5, whatever. I don't really want to say. I'm just randomly putting numbers here. Okay, now here we got a list. Now let's just say if we want to add another value to the list, you can do that by x.add, and we can just say 20. Then I'm gonna print ln x. Let's run this code. So we'll do Groovy source/list, enter, and you get to see 20 is appended. So add method is pretty common. Now let's just say you get a data in a list and all of them are numbers. You want to sort them. So you can do that with the sort function. So I'm going to use this sort, and then I'm going to print ln x. You'll see our list will be sorted. So we got 1, 3, 3, 4, 5, 5, 6, 6, 7. Okay, there's no 20 here because we are not appending anything anymore. Next method we're going to look at is pop. Pop will get rid of the value from the start. So let's just use pop method. I will run the code, and you'll see we are missing 1 because it's getting rid of it by using this pop method. We'll go and take a look at what else we can use. So we've seen sort method, we use pop, and we have a remove. Basically, it will remove the element at the specified position by remove. So let's go back to the code. I'm going to use remove. I'm going to just say 0. Let's run the code, and you'll see we will be missing 1. We are missing 1. The reason for that is because we are removing the index 0, which is the starting index of x. So all the lists are 0 index space as well. Now, if I want to get rid of 3, I can do that by defining index 1. Let's run the code again, and you'll see we get the 1, but we're missing 3 now. So remove function will remove an object from a list at the specified position. And the way you would specify the position is by specifying its index. Next, we take a look at another method, which is contain. And that is very, very important method. You're gonna have to check a lot of times whether that specified value or specific value exists in the list or not. So if you want to say, I want to check whether the value 1 is in the list or not. So I'll do a print ln. Let's get rid of this, and I'm going to run the code. You'll see return would be true because it is, present in list X. So if I change this to, let's just say 10, let's run the code again, and that will return false because 10 is not available. Now if I add 10 and run the code again, you'll see it will return true because 10 now exists in X. I would highly recommend that you go through this list and try these methods in list. What about date and times in Groovy? Date and time is a very common thing that you're gonna face in your development career. Whether it's Groovy, Java, Python, C, date and times are basically everywhere. You're gonna have to work with date and times, and every programming language provides date and time API, and Groovy does so. So the class date represents a specific time in millisecond precision. Simple constructor is date parentheses. Let's go to IntelliJ. To create a date, it's fairly simple. We just do def date equal to new date, and then I'm gonna just print ln date object in the console. So let's run the class. I'm gonna type Groovy source/date dot Groovy, enter, and you get to see current date. Return date has its standard default formatting applied here. We can see we got Saturday, October 17, which basically starts with Saturday as a day, and then the month, and then the date. Then we have a time, then we have a time zone and year. Now, in every programming language, date and time class can have some functions which are helpful to use. Here we got the after method, equals method, compare to method, toString method. So right now, we have a type as date. If you want to convert this date to a string, I'll just simply type dot toString. Save the file, run the code. Now we get to see the same kind of like a string, but it is actually a string type. And here we can see we got some other methods. After, equals, compare to. I would highly recommend to go through and try these methods out. To find out more about these methods, you can go to the documentation for date class provided by Groovy. That's about it for dates from this video. I'll talk more about dates later in the course. Welcome back. In this video, we're going to talk about maps in Groovy. A map, which is also known as associative array, dictionary, table, and hash in other programming languages. Basically, it's a unordered collection of object references. The way we create a map is by having two things, key and its value. Here is an example. So we got a topic name, which is key, and we got list as a value. We got topic name, which is a key again, and value as maps. We need to make sure that we separate key and value using colon, and also because it's a collection of unordered key value pairs, we have to separate every key value pair with a comma. Here is an example for empty map. I'm going to read this passage. A map, also known as an associative array, dictionary, table, and hash, is an unordered collection of object references. The element in a map collections are accessed by key value. So let's just say you have an object within a map and you want to access just that particular object. The way you access it is by defining its key. In this case, we have a topic name as key. Next, we have a key used in a map, can be any class. We got some functions there as well. For example, we have a contain key, which basically checks whether we have a key within the map. We have a get function, which look up the key value in a map and return the corresponding value. We have a key set, obtains a set of keys in the map. Next, we have a put method. It associates the specified value with the specified key in the map. Next, we have a size method, which returns the number of key value mapping in the maps. Next, we have a values method, which returns a collection of values contained in the map. Let's take a look at everything in IntelliJ. So now in IntelliJ, we got a class called maps, and then we have a main method there as well. I'm going to start by creating a very simple map here. Let's start by defining def, and I'm going to name it map A equal to, and then we have to have a square brackets. Now there's two things to create an object within the map. We have a key. I'm going to just name it key colon to separate it from value, and then I'm going to just simply type value1. Now to add more collection to this, I'm going to type comma. Second key name we type 2, key 2, and then a value for that would be, let's just say value 2. Now this is a very simple map. We are going to use println function and just print it in the console. Let's run this file, and we can see we got key 1, value 1, key 2, value 2. Now we just talked about we have some methods that we can use on maps. We got a get method. Let's try that. I'm going to call .get, and I'm going to simply say key 2. That has to go as a string. Let's save the file, and now I'm expecting on the console just to have key 2 value, because here I'm saying, hey, go ahead and look up in map A and find a key 2 for me. So let's run the code. We get the result value 2, which is the value of key 2 key. Now with the get method, you can get any key. Let's go back, and we have here contains key. Well, this will return a boolean. I'm going to change this get to contains key. Let's save the file, and now let's run the code. It will return me true because it go and looked up in map A and figured out if the key 2 is available in map A. It did, so it returned true. Let's go back to the article. We have put. I'm going to use put method, add key value pair in map A collection. So start by specifying map A dot put. This require two things: a key in a string and a value in a string. So we use single quotes. I'm going to name my key 3, comma, and value 3. Change key value and check for it if that exists. Run the code and you get true. Let's try printing the value for that. So do println map A dot get key 3. Save, run the code. You get value 3. Map is very popular data structure, and it is usually used in a lot of programming language to store data because it provides a lot of functionality, which makes it very easy to retrieve a data. We have keys, values pairs, which means we can ask for any value by just specifying its key. Mastering map is fairly easy. As you can see, there are built-in methods available for us to manipulate key value pair within a map. Welcome back. In this video, we're going to talk about exception handling. Exception handling is required in any programming language to handle the runtime errors so that normal flow of application can be maintained. Well, to explain that, I will just give you a simple example. For example, you are going to use a mobile application and then somebody wants you to tap on a button. And what the button does is it sends a request to the server, which does some processing and return the response back. So as a user, I tap on a button, my request goes to the server, and server sends the response back, and my code, which is written in Groovy, does not understand that response. That response is something weird to this code. In that case, Groovy code will break, and we call it in a Groovy language is an exception. So exceptions thrown by the Groovy code, which means the program is no longer working. So what we need to do is we need to handle those kind of scenarios, and that's what we're talking about in this video called exception handling. Now, given that there's a class here, for example, you have a file and you're trying to read that file. Now let's just say that file doesn't exist. You don't have that file, and that exception will be thrown. And when the exception will be thrown, the program flow, the common program flow won't work any longer. So to handle that, we are going to make sure that even though our program throwing an exception saying file does not exist, well, we still want the other part of the application to continue as we expect. So file doesn't exist, just show the user that, hey, file doesn't exist, create a new file with this specific name, and let the user create new file instead of just saying, hey, you have caused a problem, the file doesn't exist, and I'm not gonna let you run this code anymore. So we want to handle those kind of scenarios, and we can do that by using the term exception handling. So given an example here, we got something like try and catch block. So a method catches the exception using the combination of try and catch keyword, and a try and catch block is placed around the code that might be generating an exception. So here we got try block, which basically going to run the code, and if there is any error comes out of it, that will be handled in a catch. And catch, you can do whatever you want to do, but it will not break your program. IntelliJ and try it out. Here I've got an exception.groovy file, and here we can see we're trying to read a file which doesn't exist. And I'm going to read with file.readlines, and this is basically the code which will run after the exception is raised. Because this file doesn't exist, it's going to go and throw an exception, and then after that we will see that this code doesn't run. Okay, so let's go and try running this code. I'm going to just make the terminal a bit bigger, and I'm going to press enter, and you'll see the code thrown an exception, which is a type of java.io file not found exception. And we basically break our application because this line, which I was expecting after that exception is thrown, would just run. Well, it does run. This is where the runtime will basically break and your application will stop working. So to avoid these kind of scenarios, what we can do here is we can wrap this in a try catch block. So we do try. I'm going to just do something like this, and I'm going to do a catch, and error basically was thrown was file not found exception, and we can just name the variable e, and then here we can say print ln, and we can say file not found. Okay, and now we'll see that once we run this code, same exception will be thrown, but that exception will basically be cached here. I'm going to do something like concatenate with e. Save the file, and now let's go and clear the terminal first and run the Groovy file. Now it says file not found java.io exception hello.txt, no such file found, and it says code running after the exception. Now as you can see, the exception was raised and our program actually had an error. But the reason why it didn't break and it went on running is because we wrapped that in a try and catch block. Try catch block is very, very useful. You have to make sure that you use try catch block where is required, where you feel like the code is going to break, or there might be something wrong with the server, or something wrong with the file not being there. So all those scenarios has to be has to have a code in a try block, and then you catch those exceptions. So in that case, your program will not break and you will have your other part of application running properly. Now in the article, as we can see, we got a multiple catch block. So what you can do is you can add multiple catch blocks. For example, here it is actually catching file not found exception, but I can do something like catch, and then I'll simply just have a java.lang exception, and that would basically just catch the exception. So I'll just do this. Now, this case, you can catch different types of exception in one try catch block. So this says file not found. Maybe the file is found. Maybe some other code that you're trying to read does not exist and something is wrong. So you can have like a general exception block here, which can, catch that exception. So you can do like a multi-catch block. Also, we have a finally keyword within try catch. So we got try, catch, 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 and then finally. So only thing the finally block does, it will always execute irrespective of occurrence of an exception or not. So it doesn't matter if the exception is there or not. If I use finally block and I move any code there, that would be executed. Doesn't matter what happens with the exception or not. It's basically going to run in any case. That's our finally block. And then we got some, messages as well. So following the exception methods available in Groovy. So we got get message, get cause, toString, print stack trace. We got stack trace. So there's a lot of examples in the article that you can have a look as well. So I will leave that to you guys to think about where your exception handling should be implemented and how you're going to manage your code, which makes sure that it does not break in the case of exception. Welcome back. In this video, we're going to talk about inheritance. Inheritance is one of the main concepts in object-oriented programming language. Inheritance can be defined as a process where one class acquires properties and methods from another. With the use of inheritance, the information is made manageable in an hierarchical order. The class which inherits the properties of other is known as a subclass, a derived class, or child class in many other programming terminologies. And a class whose properties are inherited is known as a superclass, a base class, or parent class. Some people call it base class, some people call it parent class or superclass. You can call it whatever you want, it's totally up to you. Different programming languages have different terminology. Now the keyword that it's very important is this extend. Extend is a keyword used to inherit the property of a class. Given below is the syntax. So what we do is, for example, we have a person class. This class has one instance member called a name. Creating a class called student, which extends the person class. Note that the name instance member, which is defined in the person class, gets inherited the student class. And in the student class constructor, we are calling the base class constructor function. In student class, we are adding two additional instance member of student ID and mark1. I'm not going to use mark1, but let's go down and see what's happening here. All right, let's go and take a look at this. So we got this example class, which is like just creating a new instance of a student class. And what we're doing here in a student class, we got an extend keyword, and extend keywords is followed by a person. A person is actually a class here. A person has a property of name and a person constructor function itself. Then we have a student class which extends person, and then we have a student ID and mark1 in integer. Then we call its constructor function, and within the constructor function we're going to call this super. Okay, that's what it's going to let us inherit the properties from a person. Super is basically a short form of creating a person class from its constructor function. Let's go to IntelliJ. We had this code from the last video, so I'm just going to remove the interface and the implementation of that in student. Also, I would like to move this student name into a person class, which we will inherit. So let's start by creating person class, and we're just going to use a public name property, which is going to have a type of string. Also define a constructor method for it. So I'm just going to do public person. And now we can inherit this class by using a keyword extend. And inside of a constructor function, we are going to use super. Let's modify some code in student class. We don't need a student name anymore. Also, we are going to remove the getters and setters for student name. So let's get rid of that. And then also here, we don't really need that get student for now. We already demonstrated why we use that. So here we got a student ID and then the white set student ID. Now this is private. Just for a demonstration, I'm going to make it public, and we're going to get rid of setters and getters. So here we got student name is equal to name. Let's not worry about that. And then we are going to simply get rid of the arguments for our student constructor as well. And let's get rid of this. Okay. Now I'm going to create a new instance of a student class, but we won't be able to use these methods, so let's get rid of that. And also let's just get rid of one and Paul. Now when we create a student class, I would like to use student dot, and you see there's a property called name suggested by IntelliJ. Why is that? And where this coming from? We don't have a property or attribute of student's name. But what we're doing here is we are extending this with a person. When we extend this with a person, we get all the properties from a person class, which means if we have another class, like for example, I'm just going to copy this bit and I'm going to create a new class and I'm going to name it student1. And then for the constructor, we got student1. Okay. And then we have a second class, which is student1. Oh, let's just do 2 to make it easier. So we got student class and we got a student2, and I'm also going to create class, and I'm going to make it student3. And then we need to change the name for that, student3. All right. So now when we create a student, for example, this student new, and I'm going to see there's a name property, and there's going to be also student ID property available. I can use this property to set the value, so I'll also say 5 or maybe 1 for now. And then we can say student dot student name, which is just a name property. I'm going to name it Joe. If I do a print and then we'll do student dot name, I'm going to run the code now. Let's do oop, and we get to see, oh, there is an error. It says the starting constructor function's got some issue. So we got a student, that's student, student2, and here's a constructor function that we forgot to change. Okay, let's save that. Now no more errors, so let's go and run our code and we get to see Joe. Okay, so now we have the reason why we created this person class. Okay, so let's just say that you have 1,000 students in your class. You're gonna have to define a name property for every student class that you're creating. So you got a student, student1, student2, student3, and every student, just like student ID here, will have to be, have this property specifically written. Now let's just say that you want to have that attribute available to 1,000 students. Instead of defining them into every student class, which you will have to write that 1,000 times, you can just create a base class, or you can subclass, let's just say a person, and then you can inherit that instead of just creating a name property within the student. Now if I want to just say every student will have a student ID, I can actually cut this and move that here. Okay, now this student, all of these students will have this student ID. We don't need this bit here. So you can see I don't need to actually have these two properties in all the students that I create. Now maybe this student have some a special property. For example, here we can say public, and the property would be to say DOB equal to, for example, we just leave that empty for now, or maybe we can just initialize some values. So let's just say 1, 2, 3, 4, 5. All right. Now I'm gonna go and create another student. So we'll just use a type as student2, and we just say student2 equal to new student2. And then when I take a look at student.name, and also we know that student name will have this Joe property because we're defining that here. I'm going to get rid of this student ID for now. I'm going to try printing println student2 dot, and you can see now we get the name, we get student ID, but we also have date of birth. So if I run the code now, you'll see Joe and then the date of birth that we defined for the student class. But what about the database DOB or date of birth for this student? So if I try to println student dot dob, let's run it, and there you go, you get an exception. It says missing property exception. Well, no such property DOB for class student. Well, that's right, because this is only available to student 2 because we're defining it here. So this is where the inheritance comes in. What you need to do is you need to figure out what are the common properties that you require from some sort of like functionality. You put them into one class, we call it as a base class or superclass, and then you inherit that into a child class, and then you create an instance of that. This way your code can be less, and then you can write better and use the proper object-oriented programming. Concept we want to talk about is abstract classes. This person class is being used in student classes, so we got student, student 2, student 3, which all extending this person class. Now in our main method, I'm gonna first of all, let's get rid of this line so we don't have any error. Now if I say I want to create a person, and that would be just the person equal to new person, and I'm gonna save the file, and let's do person.name property equal to, let's just say, Paul. Now I'm going to, first of all, let's get rid of these two print lines so we don't have exact log that we want to do. So I'm going to do println, and I'm going to say person.name. all right, now I'm going to run the code, and you get to see we got Paul. Now sometimes you want to create a class which should not be instantiated. Here we're creating a new instance of a person class, but this class was not meant to be created by any other class. It meant to be only inherited into its classes. So why we are able to create an instance of this class? Because I don't want to create a direct instance of this person class. Now if you want to avoid that, you can mark this class as abstract class. So if I do abstract class just before the class keyword, so we do abstract, save, and now if I try to run the code, you're gonna get an error. It says groovy.control multiple compilation error exception start or fail. So it says you cannot create an instance from an abstract class. So we can't really do that anymore. In the article, I'm gonna read this paragraph. So we got abstract classes. Abstract classes represent a generic concept. Thus, they cannot be instantiated, being created to be a subclass. Their members include fields, properties, and abstract or concrete method. Abstract method do not have implementation and must be implemented by the concrete subclass. You got that concept now? Sometimes we want to create a class which should not be instantiated but should only be inherited into subclass. So also we have abstract methods which should not be implemented and must be implemented by the concrete subclass. So now we understand why we have subclasses and the use of those classes. Sometimes you want to restrict that class to only be inherited instead of being instantiated. Simple as that.